So this question is coming from organic chemistry, and if you're new to this channel, subscribe for more videos like this. Chemistry is very difficult for you, especially the organic chemistry. This video is very helpful for you, and kindly watch it until the end. So the question is saying ethene, but1-ene and but2-ene are alkenes. So alkenes are referred to the unsaturated hydrocarbons. The reason why they are called unsaturated hydrocarbons, this is because they have a double bond between carbon atoms. So the question is saying the displayed formulae of ethene and but1-ene are shown in figure 7.1. So we have the first one, which is ethene, and this one is butene or but1-ene. So question A is saying, state the general formula of homologous series of alkenes. So the general formula of the homologous series of alkenes, it is CnH2n, where n is going to represent the number of carbon atoms. CnH2n. So this one is the molecular or the general formula of all alkenes. Question B. But1-ene and but2-ene are structural isomers. State the meaning of the term structural isomers. So the meaning of the term, this one here, which is structural isomers, it is just the existence of organic compounds having same molecular formula but different structural formula. So this but1-ene and but2-ene, they are going to have same molecular formula, but the structure is going to be different. So what it means when you say structural isomerism, if you have butene, so this means that when it comes to the structures, they are going to have different structures, but the molecular formula, it is just going to be the same. So butene, it has the molecular formula of C4H8, meaning but1 and but2-ene, they are going to have the same molecular formula, which is C4H8, but the structure or the structures are going to be different. In Roman number 2, it is saying, draw the displayed formula for but2-ene. So now I'm from saying that butene, it has C4H8, and usually alkenes, they have a double bond. So the first thing, I'm going to start with but1-ene. So when you're drawing the isomerism, or when you're drawing the isomers, so when drawing isomers under alkenes, we consider the double bond, where the double bond is. So here we have 4 carbon atoms. So I'm going to say C with a double bond, another C, another C, another C. So we have 4 carbon atoms here. Now, this one here, we can say here we are going to have the hydrogen atom. Even here we are going to have an hydrogen atom. Here we are going to have an hydrogen, and so on. Once you are done with putting the hydrogen atoms, naming this isomer, you need to look at the position of the double bond. So this double bond here, it is at carbon number 1. So this one we are going to call it as but1-ene. Now from this question here, they are asking us to draw the structure of but2-ene, meaning the double bond is going to be on carbon number 2. So let's draw the structure. So we are going to say C. Here we are going to have the single bond. Then the double bond is going to be at this point here at carbon number 2. Then we need to fill up by putting the hydrogen atoms like this. Okay, so So that is how the structure of but2-ene looks like. So the next one is saying but1-ene is unsaturated hydrocarbon. That's why but1-ene is an unsaturated hydrocarbon. So the reason why but1-ene is an unsaturated hydrocarbon, this is because it contains a double bond. So a double bond is just like this one here, where we say C, then we put two bonds here. That's a double bond. So we are going to say because it has a double bond. Roman numeral number 2, state why but1-ene is a hydrocarbon. So hydro, it is coming from hydrogen, and then carbon is coming from the carbon atom. So we are going to say it contains hydrogen and carbon atoms only. Then as for the next one, which is D, but1-ene reacts with steam in the presence of a catalyst and reacts with bromine. Roman numeral number 1, draw the structural formula of the product of the reaction with steam in the presence of a catalyst. So when but1-ene is an alkene. So alkenes, they react with steam or water to produce an alcohol. This process, it is also known as the hydration, because water is going to be added to an alkene. If I even draw that one, let me just try to write the chemical equation. So we are going to have but1-ene, which is C4H8, is reacted with steam, which is H2O. Now in this case here, this one is going to be in gaseous state. What is going to be produced here? It is the alcohol. Now this alcohol, it is going to be butanol. So they are asking us to draw the structure of butanol. Now, what we are going to do here, let's try to write the general formula for alcohols, for all homologous series of alcohols. So the general formula for the homologous series of alcohols, it is Cn minus 1, H2n minus 1, then Q at the end here. And sometimes in other books they are going to write something like Cn H2n plus 1, then Q at the end here. These things are just the same, but I'm going to use this one here, which is very, very simple to understand. So butene, it has 4 carbon atoms. Now here we are saying minus 1. So if I put 4 here, I'm going to say 4 minus 1, and then I'm going to have what? 3. So you can say C3, then H. So if I put 3 here, I'm going to say, so if I put 4 here, I'm going to say 4 multiplied by 2, I'm going to get 8. 8 minus 1, I'm going to get 7. So it's C3H7. Then at the end, I'm going to put Q. So this is how we write butanol, which is C3H7COOH. That is butanol. Now they are asking us to draw the structure. So how many carbon atoms do we have here? As for the first one here, we have 3. So I'm going to say 3. Now remember, butanol, it's not an unsaturated hydrocarbon, so it is going to contain a single bond. So you can say C, another C, another C. Then we put the hydrogen atoms here. Even here, we need to put the hydrogen atoms. Okay, so we also have another C here, where we are going to have a double bond here for oxygen. The reason why we are putting a double bond here for oxygen here, this is because oxygen has a valence of 2. Then at the end here, we are going to put the hydroxide. So let's just put the hydrogen atoms here. So this is how we draw the structure of butanol. Then as for Roman numeral number 2, draw the structural formula of the product of the reaction with bromine. So butene, which is C4H8, has been reacted with bromine. So bromine exists as a diatomic molecule. So what is going to be produced here? It is dibromobutene and hydrogen. So two things are going to be produced. So the first one is going to be dibromobutene, Then the next one is going to be the hydrogen gas. Okay, so we have dibromobutene and the hydrogen gas. Now, dibromobutene looks something like this. Here we are going to have a double bond. So C double bond, another C, then another C. Then at the end here we can say hydrogen. Now they are just asking us to draw the structure of the product which is going to be formed when but1 reacts with bromine. So what is going to be formed is the dibromobutene. So that is what they are asking us to draw. So if you can remember very well, I said bromine, if you can remember very well from saying that bromine exists as a diatomic molecule. So meaning here if we have hydrogen, here we are going to have bromine. Even here we are going to have bromine. Then the rest are going to be hydrogen atoms. The rest are going to be hydrogen atoms. Okay, so if here we are going to, so the rest are going to be hydrogen atoms, we can say. So that is how we draw the structure of dibromobutene. Dibromobutene is going to be obtained from the reaction of but1 and bromine. So that was the last one. Thanks for watching and see you next time. Peace.